Okay guys, so now let's move to our first question, 9.2.1. And before we move to that question, there's a statement also given there which says when switch S is closed, a high resistance voltmeter V1 across A and B reads 5 volts. Calculate 9.2.1 current delivered by the battery. Okay, so for this question, we're expected to calculate the current delivered by the battery. So our question 9.2.1, the question expects us to calculate the current delivered by this battery. So obviously the first step is to write the formula. We know our general formula, the V is equals to IR. So with this kind of questions, guys, you need to have the basics of the circuit. You need to understand what it means by the current, what is the resistance, and what is the voltage, of which at this stage I assume you might be having a bit of background with regards to the circuit, but I'll just indicate that the current flowing throughout the circuit, it should be the same. I assume you understand that part, that when it comes to series connection, remember we've got either series or parallel connections in circuits, but in this case we're only focusing on series connection, so there's no any parallel connection along this circuit. So that means we'll only apply the basic principles of series connection. That's why I'm confidently saying a current flowing throughout this circuit is the same. So from the statement, remember, from the previous statement, actually the main statement, we're given the effective resistance between points A and B as 6 ohms. That means the combination of these two resistors is equals to 6 ohms. And from the statement that I just read now, we're told that across A and B, a high resistance voltmeter across these 2 points is equals to 5 volts. So that means the current passing through this resistor N, it should be equal to the current passing through this resistor M, and again as the same current passing through this resistor T. But in this case, remember the values that were given, it's the values of these two resistance. So if we make use of these two, if we make use of the information for these two resistors, that means the current that we get is the current passing through both of these resistors, which should be the same current passing through anywhere along the circuit. So obviously we're given V, which is 5. It's equals to I, which represents the current, and the effective resistance of these two resistors, it's equals to 6 substituted there. Then your I, it's equals to divide by 6, then you've got 5 divided by 6, which is equals to, let's quickly see, 5 divided by 6, it's equals to 0 point to the nearest, by rounding it to 2 decimal places, it's 0.83, which is current in amperes. So that means the current delivered by this battery, it's equals to 0.83 amperes. So that means current passing through this, it's equals to 0.83. And remember guys, that only happens when the switch is closed. But if it's open, obviously no current. But then in answering this question, this is how you provide an answer to this question. So let me quickly check how many. Okay, this question is allocated 3 marks. So obviously you score a mark for the formula, you score a mark for substitution, you score a mark for final answer. So that's how you score your first 3 marks. And most importantly, guys, remember this R, it's, let me just write it this way to say this R is the R of M plus the R of N. So what I mean by that is that this 6, it's a part of it goes to M, part of it goes to N, and when you add those 2 resistors, when you add the resistance of these 2 resistors, you get 6. So I think maybe when we move to other questions, that's when it would make even more sense. So now it's 6 ohms.